Hi, my name is Luis Ramirez, and I'm doing my project 3, and my case is the 40 Hertz case. So just our first step is going to be, we're going to open up our Fluid Flow Fluent, get that ready, then I'm going to run this in Design Modeler. I can just show you what measurements we're going to be using over here. Oh, it's frozen, that's okay. Alright, so here we are, got this there, and this is going to be a 2D, as you can see right there. I'm going to click on my XY plane, start sketching, and we're just going to start off with a line. It might be kind of hard to see actually, so we're going to choose the inch. There you go. Can't really see it, that's okay. I do want to set a dimension here. So it says our height is going to be 22 inches too, and you can see it's not really in the middle, but we are going to set a constraint. I'm going to click our line and then our origin, and then it should just align itself. Alright, and we're just going to start off with the bottom of our wind tunnel, go back to our line. You can just kind of do like a rough sketch of what it's going to look like. Right? That's not what I wanted. Okay, so I mean, here's our settling chamber, and then our contraction chamber is going to be right here. Then I'm just going to go through with our test section, and then our diffuser. Oh, make sure you're clicking on the edges there. Alright, so that's basically just like a rough sketch, but now we can go ahead with our dimensions. And the first thing I like to do is, like, I just want to, not what I wanted. I just want to make sure I have the correct distance for this. So for our test section, it's going to be a height of 6, so divided by 2, that's going to be 3 inches from the middle. There we go. So now we have that all set. Then I'm also going to change this. So our settling chamber length. So H4, I'm going to change that to 15. It might look a little bit weird, so actually I'm going to change that first. Alright, go ahead with this one here. So L5, our contraction chamber, it's going to be a length of 24. So L5, 24. Oh, I don't know how I did this the first time. Okay. So it'll like just look odd for a little bit. You kind of have to tinker around with it. It might be just like an issue of how I drew my lines. So here, we can actually just reset. And then here, 15. And the first time I did this, I did just draw all my lines all together and then change them afterwards. But I mean, that's okay. Alright, and then I'm going to have the 24. You can see that goes over our line there. So I'm just going to redraw that so it's a little bit less of an angle. Because I've had the issue where I want to reset my, like I want this to be like 3 inches away from the testing chamber. It doesn't really work. So 4, there we go, looks a lot better. And then go back to our line, to our testing chamber. You can have a length of 12. And I guess at this point I will do this. So V12 is going to be 3 inches. There we go. Now it's looking better. You can see we don't really need the angle here because we know that this is going to be 3 inches away from the middle. And that just gives us what we want. But then for our diffuser, we do get an angle. Just going to do that. And then we're going to take our dimensions and do an angle. Yep. And I like to do the outside, get those little lines in there. And then we do get a 3-degree angle, so 180 minus 3 is going to be 177 degrees. There we go. Should be just a slight angle. And then we're going to adjust our length to 42. And then that should be it. At least for our lower layer. Alright, so obviously we want the other half right here. So we're going to go into modify, and then we can hit replicate. Actually, I'm going to select my points first, hit replicate. I'm going to change R to 180. Then we can click our anchor point. Alright, so you see I have my our little thing floating around. We're gonna right click and then flip by vertical. There we go. And then go ahead and hit our anchor point one more time. And it should perfectly be the same. You know, my dimensions aren't really showing, but I think we could assume that they're all the same. So now I'm just gonna go ahead and finish off our diffuser. Right, yeah. And we just make sure our lines are all straight with constraints. Horizontal. Click on that. Click on this. This. And then our vertical. And as you can see, these ones are kind of like a greenish blue. So I am just gonna hit these with the dimension. So L15 is 24 inches. And still not really, oops. What's happening? Okay. I mean, we know it works, so I think it should be fine. So back to our modeling. I'm gonna go under concepts and then surface some sketches. And then I'm gonna hit sketch 1, and apply on there, and then generate. Alright, so I'm just gonna skip ahead a little bit because for our later steps we're gonna want our midpoint. So what I like to do, I'm gonna hit tools, and then under analysis tools, distance finder, gonna hit our, oh, not that, cancel. Let's see if I can do it. Oh, well, yeah, you want to do your edge select up there. You're gonna hit our inlet and then our outlet. Oops. There we go. Oh, okay, well, I did it wrong, so give me 1 second. Don't copy what I did. Alright, analysis tools, one more time. And then gonna hit our first edge first. Okay, hit apply on there. And our second edge. Apply. Oh, okay. And then you can change it back to meters because that's kind of what I want it in. Okay, guys, I'm fumbling, sorry. Alright, now that we're in meters, I'm gonna not hit that edge, inlet, apply. And then our edge again, outlet, apply. There you go. So 2.3259 meters would be our midpoint line. And then, yeah. Alright, so we're basically done here. I'm gonna close out of this. And then can make sure that updates over here. You got that check mark, but just in case, you can click yes. And then I'm gonna open up our mesh. Oh. Starting meshing. All right. Okay, just wait for everything to load. Okay, so we can focus it on our Z-plane again. Then I do want to start off by naming my edges. Alright, edge click. And you can just click on the upper and lowers. Just call them wind tunnel walls. And this can be our inlet and our outlet. Alright, there we go. And then I'm just going to start off with our meshing. I'm going to insert a method mesh just on the whole thing. Hit apply. And then I'm actually going to change this into our triangles. And then I'm going to go back into our overall mesh. And I do want to change the element size from the default. I'm just going to change it to 1.01. Alright, and I'm going to hit update. Might take a little bit. Oh, actually, it's pretty fast. Okay, so it should look kind of scary now. It's pretty much what we want. You can see we have all our little triangles. I think that the triangle method is better for our like kind of irregular shape we have here. Because I mean, we usually use the rectangular, but this will work better for our case. Alright, so that is pretty much it we want from, that's all we want for our meshing. We can close out of that now. Back to our workbench, let that close real quick. Cool. Alright, so into our setup, make sure we're updating. Alright, now to setup, looking for Fluent, we do dope precision. I like to do 4 because I do have 4 things, 4 cores I think, I don't know. But I mean 2 or 4, either works, it's still gonna launch. Alright, and this might take a little bit. Alright, so while this loads, I'm just gonna show you. We are given this equation for our v-test section. So 0.2489 times our frequency, or motor frequency, minus 0.3718. And then since I'm doing 40, I have 40 hertz right here, and that comes out to 9.5842. And that's my velocity in my test section. But we actually want our velocity in our inlet here. So it's the v-test times the height, or what is this? Sorry. Okay, yeah. The height there, and then our length, 22. And that gives us our velocity of this, 2.613872727. I'm just gonna copy that. Then everything here looks fine, looks good. Gonna go into our models, turn on our energy, and then we're gonna change our model from omega to standard epsilon. Just gonna double click on that, just make sure everything's okay. And then we do want enhanced wall treatment and pressure gradient effects and thermal effects. Okay, and everything else should be good here. Make sure we're on standard and not realizable. And there we go. Hit OK on there. Then materials are gonna be fine. Our boundary conditions. Alright, so here's where we're gonna change something. Double click on our inlet. I'm gonna change my velocity magnitude to what we calculated here. Hit apply. Apply again because I get kind of scared about these things. Sometimes it's an update, so I like to check my reference values. You can see our velocity is still 1, but I want to compute from our inlet. And then there we go. Should update from there. And then we're just gonna go into our initialization. Hybrid should be fine. We're gonna initialize. And just, I always get this error. I mean, I've never had issues having that error, so it should be fine. And then iterations are up to you, but 150 for just the video should be fine. Hit calculate. And then it should pop up with like a little graphic. Not really sure what to make of this, but I mean, as you can see, my lines do get a little bit wonky. I mean, it's pretty much just how it goes. It should be fine. Look a little bit crazy. That's okay. And now, so I can show you how to get our contours here. Back into our Fluent, go into graphics, and then under contours, double click on that. And here we are just going to select all of our surfaces. Interior surface body is obviously our whole surface, so that should be fine. And we want to get our static pressure. Here we go, static pressure, total pressure, dynamic pressure, and our velocity. So first our static pressure, I'm going to hit save and display. It's pretty much what you should get. Here we go, matches exactly. And then our next one, our dynamic pressure. There you go. Where's that? Dynamic pressure, yep, looks the same. And then I'm going to go ahead with our total pressure. There we go. You see, have a lot less pressure here. And then I'm going to show you our velocity. Should be the first option. You save and display. There you go. Easy peasy. Just take screenshots of those and you put them in your report. And then now here's like where it kind of gets a little bit weird. We want to do our plots, XY plot, and then we're actually going to create a new surface, or a new line, sorry. And this is going to be your midpoint line. Or I'm just going to call it center line. Alright, and then here is where it's going to change. Alright, so as I said before, we found our 2.3259 center line. It is going to be a meter, so make sure you're changing your units when you do your center line. So there we go. You're going to click on our center line, and then now we can find our static, total, dynamic, and velocity. So if you haven't had your plots yet, you can write to file and then save them. I also like to do order points. I'm not really sure what it does, but I mean, it's nice to have extra things. So I'm just going to show you what everything looks like. There you go. Here's my static pressure. Dynamic pressure should be a mirror of that. And then, oops, wrong one. Total pressure should be a little bit crazy, but that's okay. and then our velocity magnitude. Here we go. Looks good. And then I did already write all those files down. Here we go. I do have all of my files here. So here's my 40 hertz. Here's what it should look like. Yeah, and all the positions will be the same for all of the files. They should be, at least, if you're getting the same center line. So here's all my values. And then I can go ahead and show you my Excel sheet. Here's where I have all of my values all together. So we've got 20, 40, and 60 hertz over here. And I did just plot all those down. As you can see, they're pretty similar. So obviously the 60 hertz will have like a higher or a way lower than our 20 hertz. Yeah, those are our comparisons. That's pretty much it. Alright, thank you.